In the end, it is my great pleasure to meet Tomáš Petrásek here with our final talk from the Drake equation to the stars and back again. That somehow encapsulates the idea of Drake equation and also our Drake project. And that's also because he is the person who is behind the main idea of this project. So I thank you very much in this place. And now, without further delaying, please start with your talk.
Thank you, Honza, very much. We are going to talk about Drake equation. Obviously, some of the things I included in the presentation have been already mentioned, so I will try to be very quick and mainly focus on those that have not been repeated so many times. And finally, we are going to fill in our own numbers in the Drake equation, your own numbers, so you can think in advance what your guesstimates of the individual parameters would be. To begin, do you believe in aliens? Or maybe to make it easier, who doesn't believe in extraterrestrial life, raise your hand.
Maybe specify the question, because if it's belief
in general,
if we are convinced that it's likely that some microbes are elsewhere in the galaxy.
This is meant in general. Who thinks we are alone in the universe? Okay, that's great because we need people who are not afraid to go against the mainstream. Have you ever seen any aliens? Has anyone seen UFO or UAP? No one? Well, I have seen some, but unfortunately I was patient enough to identify them. So. Yeah, so we already have our Fermi paradox. Most of us believe in aliens. No one has seen them. So that's a very good beginning. I will obviously start with the Drake equation. I'm really lucky because the speakers before me have already introduced the concept, so I probably don't have to go through the individual parameters. I don't need to repeat when and where Drake equation was originally written, that it was at the Green Bank conference in the wake of Project OSMA, the first radio telescope attempt to detect extraterrestrial intelligences. And you have probably all already realized that most of the factors are problematic in more than one way. The trivial way is that we don't know the exact values, or we don't know, we don't even have estimates, but also the definitions of the factors. For example, we lack definition of life, we lack definition of a habitable planet. So if we take only Earth-sized planet in the habitable zone, we might end with quite a high number because planets in habitable zones are common. But if we think about all the other conditions that have to be fulfilled for the planet to be really habitable, the number might be several orders of magnitude lower. And the same is with L, because it's the lifetime of communicating civilization. So basically, if I had a radio telescope broadcasting to the aliens, switching it on and off like this, then we can say that every switching on and off might be a separate instance of L or not, or is it physical life of the civilization? It's not really simple, and different people have different ideas how to define them. But return to the historical origin, to the Frank Drake's first writing the equation on a blackboard. The point is that his intention wasn't to arrive at the value of n, the number of civilizations in the galaxy. His primary intention was to organize the discussion at the meeting, because the topic is huge. If I asked you, are there other civilizations in the galaxy, you would offer some opinion, why or why not. But it's to talk in organized manner. It's important to separate the different topics. So that was the intention. And of course, they attempted to make some estimates, to estimate the probability of success of SETI attempts. And one thing to note is that they were rather optimistic by our current standards. And they were not the first to attempt this kind of estimate. We will get to it. What might be of interest is that the Green Bank conference was really, now it's legendary, and even at the time it was a very elite occasion, because a very small number of very privileged scientists were invited. Of course, it was organized by radio astronomers, so Cocconi and Morrison, the people behind the idea, were there. Of course, Frank Drake himself was there, and his then boss, Otto Struve, who was the leading capacity on exoplanets at the time. Of course, no exoplanets were known, but he was the person to go to when you needed some mathematical estimates, how planets would form, for example. But there were also other people. I don't have to introduce Carl Sagan, of course, but there was also Melvin Kelvin, a famous biochemist, to help with the issues of origin of life. Precisely at the time when the conference was taking place, he was informed that he was going to receive his Nobel Prize for discovering the laws of cellular metabolism. So he was quite elated and quite optimistic in general, which also affected the mood at Green Bank. And there was John C. Lilly, who was the pioneer of communication with dolphins. Now he's a very controversial figure, but then he was very famous, very influential, and also he was a huge optimist. He was so persuasive with his ideas about dolphin intelligence that when they try to estimate the likelihood of intelligence emerging on a planet with life, they went for 1. Because if it happened at least twice on Earth, if there were 2 intelligent species, then surely it must be highly probable. So those were the people. And also, because of John Lilly, they called themselves the Order of the Dolphin, like some secret society. Melvin Kelvin even had silver badges featuring a dolphin made for every one of the attendants. But this conspiracy only lasted for the duration of the conference. Afterwards, the participants went different ways. They never met again in full numbers, and many of them also drifted in their opinions, and even their opinions on likelihood of extraterrestrial intelligence differed. Nevertheless, the Green Bank conference was, I think, a major tipping point in the whole venture of search for extraterrestrial intelligence, because it affected, it made a huge splash in the media and on the international scene. Even behind the Iron Curtain in the Soviet Union and the Soviet countries, the idea of communication with extraterrestrial intelligence was widely accepted. So the, let's say, a mirror event at Burakan in today's Armenia, then Soviet Union, happened only 4 years later. And in 1971, there was even international conference open to the Western scientists organized at Burakan, which was something totally unprecedented because in most research fields, the world was divided and the scientists didn't communicate very much. And what's interesting, there is even a Czech footprint in this area, because it was Professor Rudolf Pešek from then Czechoslovakia who first suggested the acronym CETI, like communication with extraterrestrial intelligence, which was later changed to SETI, search for extraterrestrial intelligence, but the origin is from this country. So together with robots, it's another contribution of Czech language to the international scientific terminology. Many people tried to come with some numerical estimate or guesstimate of the number of communicating extraterrestrial civilization. You can see that at the Green Bank conference, they were really optimistic, predicting even around 1 billion of communicating civilizations in our galaxy alone. But then, with time, the estimates sort of went down, but there is huge variance. This is not representative selection, with many authors, even in 1970s and 1980s, arguing for essentially zero, like very improbable. Maybe another anecdote to mention that Carl Sagan was so successful in popularizing the Drake equation that for a time it was known as the Sagan equation, which he had to debunk and attribute it to Drake as it was the case. It also met with many misunderstanding or even deliberate attempts at twisting its meaning. You can very often meet with opinions that Drake equation is useless because we don't know the numbers, or even that is some pseudoscience. The most well-known example is the essay by Michael Crichton. Everybody likes Michael Crichton, yeah, but in this case, I think he was quite off the mark because he argued that because we don't know the exact values of the factors, anything we put there is just our prejudice, and the equation is just some sort of smoke and mirrors that pretends to be science, but instead it's religion or pseudoscience, which is quite a harsh criticism, and I don't think it's substantiated. I will get to it later. I think even this very meeting proves that it's much more than that. But there are also some from the other direction. There are also overly non-critical opinions, as if the equation was meant to arrive at a very precise number. Like these guys who calculated that the result is 36 and made headlines with it, which which is not even wrong, right? We all know it should be 42. Yeah, so neither one is the right approach. If we neglect such misunderstandings and take a closer look at the equation, we may notice some features or some problems, whatever you like, of the equation. It's an equation for a steady state process. Nikos already talked about it quite extensively, so I will not dwell on it very long, but it's a huge assumption because it means from the very logic of the equation that extraterrestrial civilization, there is some equilibrium number that's not rising and it's not decreasing, which is non-trivial assumption to begin with. So keep it in mind. It neglects the repeated origin of civilization, so one planet, one civilization, no more. It completely neglects the possibility of interstellar travel, which may or may not be substantiated, we don't know. And it assumes that civilizations are perfectly isolated, that presence of a civilization here doesn't increase or decrease the probability of another civilization somewhere else. Which if, for example, the colonization happens, it's not true if the civilizations, for example, are antagonistic or if they communicate and help each other. It may not be the case in every possible universe. I already talked about uncertain definitions of the parameters because, and there is sort of cumulative effect because if you, for example, give a very high number for probability of planetary habitability by including even a non-Earth-like planet, it may well affect the other terms of the equation because if you have wider pools of planets, then the probability of, for example, intelligent life occurring might be lower because you include even the less favorable planet, for example. So that we have to bear in mind. This led to many modifications of Drake equation. The simplest one is to add repeated origin of civilization, which was proposed by Robert Zubrin, and maybe he was not even the first. You can include more factors, basically whatever you like. For example, some authors have tried to include the concept of galactic habitable zone, basically limiting the equation to only the favorable regions of the galaxy. You may have term for cataclysmatic extinctions, basically that some fraction of planets is destroyed. You can input the parameters not as specific numbers, but as statistical distributions or as function of time, because obviously, for example, the rate of stellar formation is not exactly constant and the other factors may well not be as well. And you may also model the interstellar colonization. There are different approaches. One was suggested by Nikos. There is entire class of percolation models which try to approximate this spreading of intelligent beings through the galaxy by the same mathematical apparatus that you would use to model percolation of liquid through some porous media like soil or sand. And the parameters, for example, the number of suitable stellar system and the difficulty to launch the missions is approximated by different parameters of the mathematical model. We have also already met with the terms Drake equation, Fermi paradox, and the great filter, so this will not be very surprising for you. Fermi paradox is the name hints at the famous quote of Enrico Fermi, which was made at Los Alamos, probably during lunchtime at the local canteen. And the actual trigger of the debate about extraterrestrial was this very cartoon making fun of disappearances of rubbish bins in New York, which was attributed to the flying saucers, which were hugely popular at the time. And the physicists were joking about this topic, and Enrico Fermi made some very brief remark, essentially in the sense where they are. The problem with, you can find fake quotes by Fermi. You can be certain that it's fake because Fermi never published any text on the topic of extraterrestrials, and nobody present at the table made notes, so no one can know what Enrico Fermi exactly said and how it was formulated. And that's probably the most paradoxical thing, that the paradox is neither Fermi's nor a paradox. It's not Fermi's because Fermi wasn't the first to make this this series of logical steps, and among the other people who could be attributed, who this could be attributed to, he never published about it. So it could be termed Hart paradox, Tipler's paradox, Tsiolkovsky paradox, or whatever, and it would make much more sense than Fermi paradox. And it may not even be a paradox. Most probably it isn't, because it depends what your assumptions are. If you don't expect extraterrestrial civilizations to be common, then obviously there is no paradox. It only is a paradox if you assume that extraterrestrial civilizations should be everywhere. And we will actually see if it is or it is not paradox when we add our numbers together. So how to sort of rehabilitate Fermi to make some reasonable link between him and the extraterrestrial problem? I think the proper term is not Fermi paradox, but Fermi estimation, which was Fermi's hallmark method of arriving at approximate numbers. For example, he liked to ask his students some random questions which they had basically no data to answer, but he wanted some order of magnitude estimates. Like if I asked you how many dentists there are in Prague, you wouldn't know the number, but you could say there is 1 million people, one person goes to the dentist about, I don't know, 2 times per year. Average dentist would have, I don't know, something about 10 visitors per day. Like order of magnitude, it's not 1, it's not 100. And then you could make some reasonable estimates how many dentists would be in Prague. It wouldn't be precise number, but it would be a good approximation. And that's precisely what Drake equation might be if we use it that way. And that's probably the best link between the Fermi and Fermi paradox. You have already been told what the great filter is. Basically, it's the factor of the equation or any other factor you may think of. That's the explanation why we don't see other civilizations arriving to Earth or sending their signals. So it offers an alternative way how to look at this problematic, but it's just inversion. It offers nothing very much new. So now we will very briefly go through possible classes of solutions to the Fermi paradox, or possible candidates to the great filter. One huge class of explanations assumes that the great filter is behind us, that we have already passed it and we don't even know it, perhaps. One of those explanations is the rare earth hypothesis, claiming that it's the physical factors of our planet that are rare. That, for example, it may be our position in the galaxy, which I don't see as very probable. It might be the cosmic catastrophes, mass extinctions, which also doesn't appear very credible. But it may be some geological or astronomical quirk of the solar system, or the presence of the moon that might be rare. From the exoplanet science, we already know that the sun is not a typical star. It's one of the more luminous stars, but not so massive to be too short-lived. So it may be some sweet spot. It's also exceptionally quiet. Many stars are more active, have more stellar eruptions. So it may be part of the explanation, and the solar system seems not to be typical, although we may debate whether or to what extent it might or might not be observational bias, because we cannot directly observe all types of planets right now. But it seems that already we can say that we are not the most typical archetype of solar system out there. My personal opinion is that Earth might be rare not because of some single defining rare parameter, but due to very specific combination of many factors. It's like each one of you is unique. It's not because you have some very rare property, like being the tallest of all people or the most intelligent person on Earth, although we would all like that. But it's the combination of very common properties, like, you know, eye color, hair color, personality traits, because there are so many possible combinations that there is no other person that would be precisely like me. And I think that might well be case with Earth, because there are so many things that might be different. What we don't know is precisely how close we have to be for the planet to be conducive to development of communicating civilization. We might argue that there are many paths to that goal, or we may argue that we need Earth's twin, and I strongly believe that there are no Earth twin anywhere near in the detectable range. There might be interesting planets, but not precisely like Earth. There are even some recent articles like this one where they argue that even the presence of continents, both continents and oceans, which requires plate tectonics and the presence of the just right amount of water, might be exceptionally rare, like really rare, even on planets which are in the habitable zone and of the right size. So the rare Earth is not that, definitely. Then we may argue that Earth is not that rare, but that the evolutionary transition leading to intelligence are difficult and they not happen everywhere, which is basically what Honza talked about in the previous talk, so I will not stop here. If great filter is behind us, it would be perhaps, we would be lonely in the universe, but it would also mean that the stars are ours, that we are the first or one of the first civilizations to arise, and if we don't make some blunder, we might well colonize the entire galaxy, and there are no principal obstacles ahead. That would be optimistic. But there is the other option that the great filter is ahead, that civilizations arise, but they somehow not end up colonizing space and sending their signals to other stellar systems, which might be due to the L factor, like in the hard version, like civilizations are short-lived because they destroy themselves or they destroy their environment even before they have time to colonize other stellar system or before they can develop capacity to broadcast their presence widely. Or it may be that the evolutionary path of most intelligent species doesn't lead to that end point we anticipate, to the cosmic civilizations. So they end up in the matrix or replaced by some AI which loses interest in the outer space or whatever else might happen. Another subclass of explanation is that the extraterrestrial civilizations are there, but they are hiding from us. This might be the zoo hypothesis or the dark forest hypothesis, which postulates that extraterrestrial civilizations are inherently hostile to each other because they have no common grounds to establish cooperation, so they naturally compete and fight with each other. And because they don't know their neighbors, they don't advertise their presence, because that would be basically a suicide, just drawing attention to yourself when someone more powerful might be just waiting to kill you. So everybody stays quiet, and if they encounter each other, then such encounters lead to destruction of the weaker of the two civilizations. Which is sort of appealing to biologists, because it would basically mean that the universe is one huge ecosystem of predators and prey, leading to some sort of ecological balance, but that doesn't, of course, mean it's true. So if great filter is ahead, it would be either way, it would be very pessimistic for us who would like to see humans traveling to other stars and exploring exoplanets, right? And it may mean that our survival is really improbable. In this place, we can remind the quote by A.C. Clarke that either we are or we aren't alone, and both possibilities are terrifying. So that's probably why he said that. But there is a third class of explanations which say, no, Drake equation is not the way to go, it's wrong, because we are not living in a steady state universe. Which makes sense, because universe, if you compare the age of the Earth and the age of the universe, they are on the comparable time scale, right? It's not many order of magnitude. It's just a factor of few. So if we assume that the early universe was uninhabitable because there was just hydrogen and helium, that makes sense, then some time was needed for heavier elements to accumulate before you could make the first planets, the first habitable planets, which might be even stricter requirement, because for habitability you might require some very specific mix of elements. Then you need some time for intelligence to develop. We don't know. Maybe it could be quicker than 4.6 billion years, but maybe it cannot be sped up much. Maybe we are among the quickest. Yeah, we don't know, really. So it's quite plausible that right now is the first moment for civilizations to emerge, because it wouldn't be possible any earlier. If this non-steady state view of the universe is valid, then it would make sense for us to be right at this very moment of the time axis, because we couldn't have been there any earlier, because that's excluded, and we couldn't be there any later, because later the universe will be completely colonized by the cosmic civilizations, which would prevent further civilizations from developing. So it makes sense that any newly formed civilization could find itself only at that very specific moment of time, which is very non-Copernican way of thinking, but it has some logic behind it. This is perhaps the most Star Trek-like explanation, because it allows us not to be alone in the galaxy, but we would be among the first civilizations emerging. It could be really like the Star Trek universe, where there are many comparable civilizations, but it's not some older super civilization completely encompassing whole galaxy and colonizing everything. And we still could be the founding members of the club of the galactic super civilizations, which would be quite optimistic. I'm not saying I believe that, but it would be really nice. Another question. What if we are typical? Because we don't know how other civilizations might look like. Maybe those advanced ones, I don't know, close themselves in virtual reality or whatever. What if typical communicating civilization, interested in the outer space and all that, looks just like us? What would that mean? Nothing good, because we are not a communicating civilization in the sense of Frank Drake, actually. Yes, we did some broadcasts, some messages to extraterrestrial civilizations, but those are very brief and very far from each other, both in time and in space. For example, this Arecibo message, it would be very well detectable at galactic scale, but it lasted only 3 minutes, and it was sent towards a particular globular star cluster, and it wouldn't be detectable anywhere else. So the coverage of such broadcast is extremely small. It's absurdly small. Actually, the most visible signals of the Earth are military radar systems and interplanetary radar, like ranging of asteroids and other bodies of the solar system, which don't carry much information, just might be recognized as artificial signals. But even those are quite rare, and there is no attempts at systematically covering the whole sky or the interesting stellar system or whatever. So the likelihood of any of these signals hitting extraterrestrial civilizations are pretty low, and we never repeat these messages. Yeah, they are isolated attempts, most of them, or they are repeated for a very short time. So basically, if there was a civilization among the closest star system, what would they get is some analog of our wow signal, some mysterious radio signal appearing, then vanishing, never to repeat again. They would be quite puzzled. I'm not saying that the wow signal was just that or that there is such a civilization, but we should realize that what we are doing to our alien neighbors, that we are sending very, very sparse attempts of communication. Here is another diagram illustrating the extent of SETI searches. I think it's slightly dated, but it gives us some very rough idea. Here on the horizontal axis is the spatial scale, distance from Earth. And on the vertical scale, there is power of the transmitter. We can see it either way, like the aliens detecting us or we detecting them. It doesn't matter much. Here, this horizontal range means the galaxy. Yeah? Here are the closest stellar system. Here is the farthest reaches of the galaxy, and this line is the power of the Arecibo radio telescope, like the strength of the transmissions. We can do slightly better, but on this scale, it doesn't change the things very much. So you can see that we can exclude that there is a civilization sending us Arecibo messages from the nearest 100 light years. That we can exclude. There is no one pointing us with a huge radio telescope signaling constantly. But for the most of the galaxy, we haven't yet thoroughly searched even for this class of signals, because they would be too far away or the coverage is incomplete. And for weaker signals, like our radio leakage from television and radio broadcast, this would be essentially non-detectable. The observational constraints for the number of extraterrestrial civilization in the galaxy are quite weak. What we can reliably discard is the idea of some super civilizations having many orders of magnitude more energy, much larger antennas, and broadcasting in all directions. That we would really see, but that's not who we are. So we are assuming that the extraterrestrials would invest much more energy to the broadcasting, which it's possible, but it's not the natural outcome. I very much like this comics when, I don't know if it's readable, the girl asks the oracle whether we are alone in the universe. The oracle says, yes, we are alone. The girl says, so there are no other forms of life? The oracle says, yes, there are, but they are alone too, which is perhaps the most probable outcome of this line of thinking. So the Fermi paradox is not a paradox. That's one take-home message. We still don't have strong data precluding existence of civilizations like us in the galaxy. There might be many other things. There probably are many other things, but we don't know about the likes of us. And we should probably try to solve the L factor of the equation by demonstration, by surviving. That's the best way I can think of. We should be really careful about our world and our civilizations. Another take-home message, don't take Drake equation too seriously, but still it can be useful. It's a way to think about complex problems which can show us what we know and what we don't know. It may point us even towards the unknown unknowns, like we have no idea how other civilizations work, but it forces us to realize, to admit that we don't know it. And if we make some estimate, we cannot be sure whether it's accurate or not, but we can contrast it with the observations to see if there is a paradox or not. And the beautiful thing about Drake equation is that nobody knows the answer. It's not the bug, it's the feature, and that leaves plenty of room for discussion, like we will do here in a while. It may uncover our hidden assumptions, hidden prejudice, turning the space aliens into sort of Rorschach test, which is telling us more about ourselves than about our subject of study, which is sort of the rationale behind our questionnaire and the entire Drake project. So now it's time to try your own guesstimates of Drake equation. Here I have table in Excel which does the calculation of the equation parameters, and it's up to you to suggest some numbers. The rate of star formation, it's not... You don't see it? Oh. I will close it entirely. Do you see the equation now? No. There is some problem, I think.
You need help, you just need to do it.
Yeah. I think it's the aliens trying to prevent us from finding them, yeah? I try to duplicate the screen, but it doesn't work.
Try to duplicate?
Yeah.
I will just...
It doesn't show something on the computer.
Yeah, that's
the other computer.
Maybe close the presentation if it's possible, because it caused the problem. We can now try switching it here.
Yeah. Oh, bingo. There are some numbers for the rate of stellar formation, which we may. I gave the range from 1 to 10, like how many stars form per year in the galaxy. Then we have the fraction of planetary systems. What do you think? How many stars have planetary system? Give some estimates.
0.9.
Some other estimate?
You want to hear the pessimistic ones or the optimistic?
I would consider those the optimistic, because there is no much room to go even higher.
Yeah.
So some more pessimistic?
0.1.
Okay. That's quite improbable. But yeah. Then number of habitable worlds per typical planetary system.
I don't know which category this should be, but I have 0.0864. I just did a fraction of like celestial bodies that should have water in our system over the main big ones,
like this.
6.4. Yeah.
864. Just this, like this.
No, with the 8 before the 6.
864. Okay. I will keep it here before other estimates arrive.
I would guess maybe 0.2.
Mm-hmm. Another estimate.
0.1.
Okay, but that's quite close.
Okay.
Something more.
0.001.
0.001, like this.
Habitability is different.
Yeah. I would also go for a lower number. Then probability of life emerging.
I would say, from what I was saying, in some like very high number maybe, but still, it should be planets that are suitable for the emergence of life, right?
Yeah.
Maybe 0.99.
Mm-hmm. I think nobody would top that.
We have a suggestion.
Let's say for the middle one, 0.014 or something like that.
Like this.
And where's that from? Slightly more.
I just thought that from what we know that Mars, Venus, and Earth are the like only ones that there were some hints of like some activity. There was like phosphate on Venus, and now the new stuff on Mars. So if I'm very generous, those 3 out of the original 220 that I used for the first one.
0.1 somewhere there.
0.1, okay.
The ordering is in the,
Then we have probability of intelligence emerging on a planet where there is life.
0.0001. How many species have we had on Earth?
And we have the whole history.
Yes. Could we do one over that number?
Mm-hmm.
That would be
I would not say it's one, it's only about intelligence. We have like multiple cases.
We can do 100 over that.
Optimistic 0.1.
Mm-hmm. Yeah.
0.001.
Yeah, if we worked with the number of species on Earth, it would be really, really low. But let's stay with...
It's a fallacy because, if you work with the total number of species, there are some that just don't have a nervous system.
Yeah.
I don't think there's enough time now, but I think it would be fun to do the fraction of the plates on a similar level, like what's the name of like ants and bees or what? Collect of something, like or something like that, and do the fraction, and then it's like cetaceans plus I don't know those insects plus cephalopods plus blah blah blah, and then over the plates of similar level in our like system, like in the terms of hundreds.
Yeah, it would make for a scientific paper maybe. Because it would be really difficult to do it properly. I once tried to estimate it as the temporal fraction. Like if you would come to Earth at a random point of time, what would be the likelihood to encountering radio broadcasting civilization?
Sorry, I'm sorry, I was thinking of the previous, you're already on the next one.
Yeah. or intelligence. It's the same.
That's
like
what I was,
yeah,
that's what I was talking about.
like
I didn't notice you were on the next one already.
yeah. No, but we can use this approach here as well. Like if we count, I don't know, that there is 300,000 years of intelligent life on Earth. If we count Homo sapiens as a species, then we can do 300,000 slash 4.6 billion, for example, and arrive at some estimate. But that's
maybe add one more zero to the last estimate, but
let's.
This policy of this steady state, because the development of intelligence is probably not in a steady state on Earth yet.
Well, for the sake of the argument, let's stick even with quite high numbers, because it might make the outcome more interesting, right? Now we have a fraction of civilizations, like what fraction of those intelligent species produces detectable signals. We practically don't, so that's one hint. All of them, okay, that's very optimistic.
Say 10 to the negative 3. 1 over 1,000.
Okay.
Yeah.
Let's go towards 3 magnitudes slower.
So 1 million intelligent species per one communicating, or well.
I will search for how many societies, human societies are.
Well, I think it would be somewhere in this range. I mean, if we have 100 years of radio communicative civilization, which is optimist, Lomenov slash 4.6 billion, like this.
Yeah, but this is another number. You are asking about the fraction of.
I know. That's, so if we take the existence of Homo sapiens, no, wrong way to put it. Yeah, then it would be very close to the middle estimate.
I think the estimate from number of cultures also goes in this direction. Having about 7,000 languages.
Okay, yeah, we can say it would be like -3 or -4 orders of magnitude. And then what's the lifetime of communicating civilizations?
I would be optimistic. I would say 10,000.
I would say maybe it's not overly optimistic, because when we think that there is really some threshold for this cosmic civilization, it would be like million.
Let's be optimistic.
I think we also have a suggestion.
A pessimist?
I'd give, like, you know, 400 years max.
Very well.
Still possible.
We're in the times already.
Actually, I think those 250, there won't be much difference, but 250 is like the mean estimate how kingdom or civilization state unit lasts.
Yeah.
Yeah, but this doesn't mean that the other culture would not continue.
Yeah, that's always.
This is not coming into the radio.
Yeah.
Oh, yeah, sure. Thanks. I'm going to be a pessimist here, because based on what you said today, it's the equivalent of like someone actually playing very loud music just right now, you know, for 20 minutes a day, and like haphazardly, you know, when he feels like it, which is what we are doing, right? Like we were obsessed with it in the 60s, but right now we have got maybe other problems. And I don't, as far as I know, there's like no program right now that would like to try again. maybe using modern methods, right? And so like the number must be much lower than years, right? Like days, in fact, hours. Like a continuous signal, and you spoke about the systemicity of that.
Do you then want to add them up? So if we played, say, a day at a time over a period of time?
That's the question, right?
Would that be a way of estimating?
I don't know if we can add it, right? Because adding doesn't mean like systematic, right?
Yeah, we are not broadcasting in all directions at once. It would be quite complicated. But we may stick with those numbers we have right now and look where they lead. Yeah, this first is the dynamic calculation what Drake did, and here is the number of galactic civilizations. You can see that for the and here is estimated distance to the closest civilization by assuming constant star density like in our solar neighborhood. It made nonsensical predictions once we start to approach the edges of the galaxy, of course. So when the n is lower than 1, then it's much larger than the diameter of the galaxy. It just hits this ceiling. So for the most pessimistic, the n is at the order of -14. So there obviously are no other civilizations in the galaxy. Even for the middle estimate, it's very low. It's 4 orders of magnitude below 1. So even then, there would be no other civilization in the galaxy. Only for the most optimistic, we had hundreds of thousands active civilizations right now in the galaxy, but there were high numbers, right? And even then, the closest one would be 500 light years away. So it would be detectable if it broadcasted in our direction, but it would not be very strong signal. It would require quite substantial antenna to intercept, and the time to establish a dialogue would be definitely prohibitive.
Maybe we can also add, just to give an idea of how much a light year is. There are 4 light years to the nearest star. So our neighbor star is 4 light years away.
Yeah.
And this is 500 light years.
Yeah. This is within the exoplanet detection distance, but it's not among our nearest stellar neighbors. Yeah. It also shows that we need a very high number of civilizations in the galaxy to actually detect some signals, or for the civilizations to be widespread, like colonizing. So it's not easy. Just for the sake of it, I also included non-dynamic calculation by including number of stars in the galaxy and summing up those probabilities in the middle without the rate of stellar formation and the lifetime, which would approximate the number of civilizations, including the dead ones, like the closest remnants of civilizations, which here, for the optimistic example, it would mean there would be one relic of civilization some 16 light years away among our closest star, even if the nearest civilization would be quite far away. Even in the middle ground estimates, there would be 2,000 dead civilizations in our galaxy, which is not completely negligible. And for the most pessimistic one, there would be no civilization dead or alive in our galaxy. So you can see that we can arrive at very different conclusions, but I think that none of them postulates very strong Fermi paradox, because even for the most optimistic numbers, the nearest civilization wouldn't be exactly next door from us, not in probable range of interstellar flight, for example, and quite difficult to communicate with. Yeah, so we have not arrived at Fermi paradox, I would say, even with the highest number we could come up with. Maybe your opinions differ. Do you think it would constitute a paradox?
Maybe I'm just actually middle estimate actually means it would be like one active civilization per galaxy cluster for this middle range, and basically zero active, typically zero active civilization per entire universe.
Yeah.
And basically it means that, and this most pessimistic one would actually mean that we would find one dead civilization per one galactic supercluster.
Yeah, that's a really pessimistic estimate. But still the numbers are not unreasonable, most of them, even the pessimist ones. So, yeah. Actually, solving Drake equation year by year with students made me sort of pessimist in these questions, which I wasn't before. So it definitely has some side effects.
What about the students? Do they become more pessimistic?
Well. We don't know because we never asked them in advance. Maybe it's the thing to try with our next batch of students, to ask them first.
So I was wondering why was the outcome pessimistic? You mentioned in the presentation that no other civilizations would mean that we could be the first one, so maybe it's the optimistic outcome.
Yeah, of course. Yeah.
Also, it would mean that we're like unique and the life is so special, you know, on Earth. Because I don't know, I feel like somewhere deep in my mind there's this weird feeling that when people start believing in aliens and stuff like that, it makes the life on Earth seem less valuable. So maybe like a kind of didactic ecological message would be more suited for, you know, that we're alone. Maybe we'll appreciate what we have here more if we don't speculate about some aliens. But that's like maybe too stubborn of a view. But that's how I feel about it.
Well, I think it would take some aggressive aliens trying to steal our planet to make us really value what we have. But being alone, in this sense, yes, it's not exactly a bad news. It also depends what actually is the great filter. If it's the L factor, then I would rather have higher numbers, because if our life expectancy is short, then
well, it was fun while it lasted, at least.
Yeah, that's one possible approach. But if I imagine the situation, a really hypothetical one, it's probably not going to happen. If we find out that we are alone in a galaxy, but there are plenty of dead civilizations around, yeah, there is some speculation about finding necrosignatures